you are here because you want to know what an inquiry project is. I'm going to explain that to you. And so we're here we are in my Canvas page for the inquiry project. Inquiry project is quite interesting, a little challenging. It's kind of like, give you the big picture. It's kind of like doing a science fair project, except instead of going home and gathering your data from, a limited amount of measuring devices at your home, we're going to be collecting our data from the internet. So this allows us to think about a lot more questions than we could with a typical science fair project. The nice thing is, the science fair project, a lot of the other hassle is the time involved, the setup, the money involved, putting things together. You don't have any of that with this. So we get a lot more flexibility in what we can ask, and there's no cost. And oftentimes, we're asking about a lot more interesting questions than we can attack with a science fair project. Okay, so let's take a look at an example, and I think that'll clarify a lot. So I'm going to start off with this one right here. And in this example, up in the corner, I'm going to be showing you what I expect to see on that PowerPoint slide. This is sort of a template you can use, but when you build yours, you won't have that up in the corner, of course. This one's on earthquakes. Let's move that up a little bit. And so earthquakes, this is Mr. Brower doing this one. Of course, you might team up with somebody and have both your names on here, or do it by yourself. More than two is crowded, so we're going to do one person or two people can work on this. And this is my broad topic, classic science topic. We can narrow it down a little bit. That's what I do with my question. The whole core of science fair projects and inquiry project is, what question are we trying to answer? And the questions are important. They need to demonstrate or illustrate the two variables I'm interested in collecting data about. And that is what will make or break this project, is the question. Your question can't be, why is the sky blue, and then we just write an answer. The question has to insist that we go out and gather evidence in the form of data, an X and a Y, gather that data, throw it into a graph, a pie chart, or whatever, and then analyze those numbers. So this is where you'll spend most of your time, is trying to come up with a topic first, and then narrowing it down to a question. So my question is, does gravitational pull from the sun affect the number of earthquakes? The Earth doesn't go around the sun in a nice perfect circle. It's an ellipse. So for part of the year, I'm actually jumping ahead. I should slow down, Mr. Brower. The next slide talks about this. Give us a little background behind your question. Why did you pick it? What were you hoping to find? So forth. So here's my little explanation comes in. And this is what you'll be doing when you get up. I don't want you to be reading a bunch of stuff. Just use some small bits of information on your slide to kind of remind you what you need to say. You're pretty much just telling us what your idea was and what you're looking for, and not rely upon reading every word, which bores the rest of the class to tears. All right, so here I say, as the Earth travels around the sun, the gravitational pull varies by 3.3%. So, and here's a little formula that shows you what's involved in generating a gravitational force. We have the two masses, the sun, Earth, and the distance between them. So I'm interested in that distance between them, which varies between July and January. Here I've got some data I collected off the internet showing us in July we're 152.6 million kilometers away, and in January we're 147.5 million kilometers. Here's a telescopic view of the sun. It's not January and July. I just grabbed one. It happened to be December and June, but you can see that in December it does look a little bit bigger than in June because we're just a little bit closer. Okay, so we're closer in January, which means the force of the sun pulling on us is greater, and I think that's what's going to trigger more earthquakes. That's my question. All right, and so hopefully you can see that in that question there is an X and a Y. I'm looking for how many earthquakes are occurring in January versus July, and compare the two. All right, moving on. Where did you get your data, Mr. Brower? Well, easiest way to do that is do a little print screen and throw that into your PowerPoint. And you can see here I've got mine from USGS. So now you know where I went. You could even take us there if you'd like. Do a little link here and then quickly take us there during your presentation. The USGS is great for earthquakes because it keeps track of every earthquake above 2.5, and I can go and that archived information. I can pull it out quite easily. So here's that data. Include your data. Show me all of your data. Put it in a table and so forth. So I went and here's a bunch of years I collected data for, and you can see it's in Excel. And so I did a little print screen and crop to throw it into here. And yes, indeed, that is 2,292 earthquakes in 2016 in January, and I've got 1,919 in July. So I did not count every single one. The USGS place, it counted them for me, so I just extracted. I don't want to go into that detail, but there's an interface in USGS that you can grab all this data. You have to go year by year and month and select the months one by one, but it went by pretty fast. All right, so I got all my data for January and July. I threw this in here. Analyze your data. Put your data into a pie chart, pie, bar, scatter chart, so forth. This is the scatter right here. This technically is not what I want to use for earthquakes, but I also wanted to just kind of figure out whether or not earthquakes were increasing over time. That's not what mine's about. I thought, man, I got all this data. I really want to see that. Are they increasing? And they seem to be going up a little bit. And so I've got those for January and I've got those for July. That's not my intention here. My intention is down here. This pie chart, which is nice, but I think I like the bar graph over here. I've got 50,294 earthquakes in July, 46,247 earthquakes in January. That's pretty significant difference for that small amount of distance between January and July. So that's kind of cool. We've got if it were like 50,000 and 48,000, that's pretty close. But 50 versus 46, to me, that seems significant. And you have to look at your data and decide whether you think it's significant or not. Analyze your data. Whatever is appropriate, use Excel or something equivalent. Now I'm taking this data that I've already analyzed and I'm telling you about it. I actually told you about it while I was looking at it. So this is somewhat a redundant slide. If you want to do the same thing I did, which is just sort of tell me what this means. Here I've kind of got a little summary of it. There seems to be a slight trend with the earthquakes increasing over time. Pie and bar charts show that July is clearly the leader in number of earthquakes. So very interesting result. However, here a tiny little spot here. Conclusion. This is not telling the audience you were right or wrong. This is convincing us, the jury, as if you are in a courtroom. We don't care if you were right or wrong. We just want to hear your evidence. So in my case, yeah, it looks like we've got something interesting going on. However, it is totally the wrong months. We're completely backwards. The results are completely backwards. July is greater than January. Why would this be? I have no idea. And it's not answering. It is answering my question, but it's saying it's the opposite. But it's kind of leaving me like, I don't know. That's kind of interesting. This may be a takeoff into another inquiry project, which you won't do. I guess I'm just trying to point out that it doesn't matter whether you find some super interesting thing, or if maybe I got 50,000 in July, 50,000 in January, and I saw nothing. That's okay. It's kind of a you get what you get. And in this case, this was quite interesting, at least to me, but it's totally opposite results. It's not matching the cause. I'm thinking it's going to be because it's closer in January. We're going to get more earthquakes, but it's further away, so we're getting fewer. It's like, I don't know. Anyway, that's what I got. So I've shared it with you, and there's my first example. Let me show you another example. Let's see. Let's close that and open up this other one. So the other one, oh, I wanted to hit the preview button here, not that. This other one may not seem like it's a science question, but this is the other beauty of doing inquiry projects is there's science. There's the classical view that students will think is science, which is geology, biology, chemistry, and so forth. But science actually permeates lots of other fields. Political science, consumer science, economics, basketball, there's sports science. It's psychology and so on. So this one's totally different and totally if you want to do something in sports or politics, economics, that's fine too. Those are all science, legitimate science topics that you can pick from. And so let's run through this one. Same layout. I got the same questions up here. I'm going to go through this one a little bit faster than the last one. My question is, does height of a basketball player affect their free throw percentage? Do taller people, it's sort of a myth buster one, or do taller people actually are bad at shooting free throws? I hear that is actually the case. So my question, again, critical, these two parts. Get the topic, something you're interested in, and try to narrow it down into a question that has an X and a Y in it. The question is not just, how far away is the moon, and you get some sort of distance there. It needs to include that the 2 bits of data that I need to go and collect. In this case, I need to find the height of basketball players, and I need to find out their free throw percentage, and then compare them. Okay, that's what I'm looking for when you present me with this information. In that question, do I see those 2 sets of data you're going to go find on the internet? If I can't see them in there, then it's not going to work. All right, moving on here. There seems to be a myth. Yeah, blah, blah. I said that. I did that last time too. Showed you my question and immediately start talking about this next slide. So we'll go on. Where did I get my data? Here's my little screenshot from ESPN. Lots of data, lots of sports data, tons and tons and tons. Include your data. So here's the data I got. I have 22 data points in all. Here's the case where I did not show all of them. And we've got the height over here and their free throw percentage. And then I've got my data visually depicted. So here's kind of the raw data, and then I need to depict it in either a pie chart, bar, or a scatter plot. So that's what I've got here. It's really hard to see this though. It's got free throw percentage over here, and then our height across the bottom. And we do see a slight downward tick as we go across here. Not, I'd say just barely going down. I mean, it's not, it's not just dropping like crazy. It's just barely going down. So let's move on here. There seems to be a trend with the average free throw percentage going down with height, but it's not a whole lot there. Not as dramatic as I thought it would be. And the next one here, there are some interesting trends with the raw data. I had to leave out all basketball players that were over 7 feet 1 inch because there were only 3 players reported that were above that height. And the same problem existed with players below 6 feet. There were not enough players to include them. So each of these dots, even though I only had this many dots, and up here I said, I forgot to mention this, I have 122 data points. These are height in inches, and this 72, this average right here represents 7, 8 players. Maybe this is 10, 15 players are average free throw percentage. So this is a lot of players at these different heights that I averaged and got these values. Okay, so jumping back down here, a little too far. Anyway, so there is there is a trend going down that does support my question, provides evidence for it that backs it up, that yes, the taller you are, you do seem to perform a little bit more poorly at the free throw line, but not that significant, not a lot of difference there. And this part at the end is, I just happened to be looking around. I don't even know why I was doing this, but in this book here, they actually I actually haven't read the book. I was just surfing. I wanted to see if other people had done some similar research, and someone has done the research as well. And they did WNBA and NBA. They collected data. This layout is slightly different. Here are all the players, one dot for each one at that height, and we've got red for the women and blue for the men, and we do see the same trend going down. So the reason why I throw this out is there's oftentimes students will do these inquiry projects, and they're pretty significant, interesting conclusions we come up with. So much so that other people in professional journals have, in my case, someone's already done this research. I didn't know it at the time, but I'm just basically reinforcing their data. But I'm just saying some of the work that we can do, even in 8th grade, is publishable, so to speak. All right. So you can take your leisure and look these over in a little more detail. Let's go up and say just a couple more things. Right up here, it says your inquiry project proposal. This is the next thing you're going to be looking at.
Charlotte Smith, Kate
Wait for the announcement to go by here.
Lily Mann, Olivia Hybert, Mrs. Bohm, Emma Lavender. You have messages or deliveries in the office.
Okay, so this document, this is where, before you start building your PowerPoint and analyzing your data, collecting your data, you need to approve your inquiry project proposal. It's really critical that you are headed off in the right direction. And that means you've got a good question. So basically, you're going to be showing me this paper. It doesn't have to be this paper exactly. It could be some other paper with your names on it and the question written out. Because it's that question that's critical. That question's got to show, built inside of it, that X and Y. What is you're trying to compare? And if I can't see that, if you can't see that, then this whole thing's you're gonna crash and you're gonna burn. So you can start off with that, get that approved. I'll of course give you time to look and think of things and so forth. And then once you've got a good question, the rest, everything just sort of falls right into place naturally. And here I've got another little document. If you would like to have a little more breakdown of an inquiry project, another way to look at it, the kind of the pieces that you would cover in your PowerPoint. It's not exactly laid out like a PowerPoint, of course, but as you can see, it's just a scientific method, and working your way through, you might find this way of looking at it useful. Like you're going to be flowing through these ideas in your presentation. But of course, it's not about the presentation. It's about you actually coming up with an interesting hypothesis and then gathering that data online and then seeing what the result is. I think you'll find this fairly interesting, and especially if you make it personalized. You actually come up with a question that you're genuinely interested in answering, then you'll have be a lot more enjoyable. So I think that's everything I needed to cover. I didn't want to make this video too long, but as you can see, it's like explaining a game, and once you explain it to them, they look at it, oh yeah, I'm a big gamer, and I often explain a lot of games at the beginning. It seems confusing, and how does all this work? What are these spots where you put your pieces? And once you explain it, you start playing, it's like, oh, everybody goes, oh yeah, I get this now. This is not the big deal. It's that way with this. So, all right. Just seeing if there's anything else I missed. I think if I missed anything, you can just talk to me in person. Okay, so we'll end the video here.